All right, today we're going to learn about law of sines. Goal 1, solve non-right triangles using law of sines. So there's a big note here that says do not use right triangle trig, which is SOHCAHTOA, on triangles that do not have a right angle. I'm going to add another thing not to do. Do not use right triangle trig. And then we also need to write or Pythagorean theorem. These only work on right triangles, so do not use those if it's not a right triangle. Okay, now I'm going to draw a triangle over here, so in the shape of it's not that big a deal, however you want to draw it. I'm going to label angle A here, angle B here, angle C here, and of course, wherever you put your A, B, and C doesn't matter as long as opposite angle A goes lowercase side A, opposite angle B goes lowercase, which is side B, and opposite angle C goes lowercase, which is side C. Now, right here, I'm going to write the law of sines, all right, or right next to this arrow. So, when we write the law of sines, it's a formula. It's just a series of proportions or fractions equal to fractions. We're going to take this side A and divide it by the sine of the angle opposite side A, which is, nicely, sine of angle A. That's going to be equal to side B divided by the sine of the angle opposite of that, which is, again, nicely, sine of angle B. And then the last one, which you might guess, if we're looking at C's, we will take side C over the sine of angle C. And because there are sines in there, that's why it's called law of sines. All right, now, there are two types of triangles we will use this on. Use on one, an angle-angle-side triangle, which is abbreviated AAS, and 2, an angle-side-angle triangle, which is abbreviated ASA. Okay, example 1. Solve triangle ABC given the following information. Angle B is 28 degrees, angle C is 130 degrees, and side B is 26. So I'm going to draw a triangle here. Keep in mind that C is supposed to be an obtuse angle, so a little bit greater than 90. So this is C, and I'll make this A, and I'll make this B. All right, and then the given information here, I know angle B is 28 degrees. I know angle C is 130 degrees. And I know B is 26, which goes across from angle B. All right, and then I'll go ahead and label this side as A and this as C. Now I want to tell what type of triangle it is right away. So right away, of the two that I talked about above in the notes, it's an angle, angle, side, because that's what's given. So I'm going to write this off to the side, and it's going to be very important that we determine the type of triangle so we use the correct formulas. All right, in the future you're going to learn some formulas that don't work on this type of triangle. All right, so now I'm going to go ahead and find the easy stuff first. Angle A. I'm going to box this. I'm going to keep my work really organized. So when I look for A, we know the sum of the angles in a triangle is 180. So I'm going to take 180. So I'm looking for angle A. Minus 103. Minus 28. And just do that in your calculator real quick. A is going to be 49 degrees. And I'm going to write this here because I found it. And I'm going to have to use that in the rest of it. Sometimes you're forced to use information you find in the rest of the problem, and this is that situation. All right, I can find side A or side C next. I'm going to go ahead and find side A. Let me underline this. And the other thing I like to do is put all my answers together in one spot. So A is 49 degrees. And then I'm looking for A, but I'll put little a over here and then little C. And if you keep your work organized and your answers all in one spot, it's easier for us to grade stuff. All right, so anyway, let's look for side A. And I'm going to set this up using the proportions we talked about before. A over the sine of 49 degrees. So A over the sine of the angle opposite of it, which is 49 degrees, will equal. Now I don't want to use C because then I'll have too many unknowns. I want to use the side and the angle that I know. 26 over the sine of 28 degrees. When you write this equation, and notice we're only going to use 2 at a time, not 3 like we have up in the top. You should only have one of these you don't know, so we can solve it. All right, so let's multiply both sides by this denominator, and I'll be able to solve for A rather quickly. So multiply both sides by sine of 49 degrees. Now it's really like that over 1. And this will cancel that denominator. And then right away I'll be at A equals 26 times sine of 49. All over sine of 28. And so A will equal, we got our calculator out here. And let me clear this. So the first thing we want to do is make sure we're in degrees. So hit mode, and then I'm in degrees. And then so I'm going to hit second, quit. And I'm going to type in 26, sine button, 49. I'm going to close parentheses, and what I like to do with this real quick is just hit enter here and then divide by, and don't forget to divide by, the sine of 28. And then you have to worry about a ton of parentheses and typing this in all in one statement, and you can get the answer without too many mistakes. And so when you divide by the sine of 28, then you get your final answer for A, which is 41.8 inches. And this is right here. I'm going to go ahead and write this up here then, 41.8 inches. And then I'm going to go ahead and find C. I'll just use a different color here. I'll use blue. And I'll find C right here. Very similar setup. I'm going to take C, which is over here. C over the sine of 103. So C over the sine. Here, let me make a little space here. C over the sine of 103 degrees will equal, and I can use this same 26 over sine of 28. And notice again, I'm not using SOHCAHTOA, I'm not using Pythagorean theorem. All right, so multiply both sides by this denominator and this value right here. So I have sine of 103 over 1 times sine of 103 over 1. Cancel. So C will equal 26 sine 103 degrees all over sine 28 degrees. Now, you type this in the same way you do the other one, just the numbers are a little different, and you'll get C equals, sorry about that, C equals 53.96. And again, we're in inches, and I rounded to 2 decimals, so 53.96 inches. All right. At the end of the problem, I like to just box all my answers together. So over here, and now we'll move down to the next problem. All right, so part B, while this is scrolling, A is 36 degrees, B is 64 degrees, and C is 17 meters. We're going to solve this triangle. And this one's going to have, these angles are pretty small, so I'm just going to draw it like this. I'm going to put A here, I'm going to put B here, put C here, and again, in another color, it's nice. I'll go ahead and label what we know. A is 36 degrees, B is 64 degrees, And we know C, which goes here, is 17. We know lowercase b is here and lowercase a is here. Now, what type of triangle do we have here? Actually, let me change these so I have be consistent. This is not what was given. We're looking for it. Not a big deal, but anyway. What type of triangle do we have here? We have angle, side, angle. So I'll write that out over here. A different type of triangle, angle, side, angle. But solving this is going to be very similar to the other one because I'm given two angles and a side. But it has to go in this order, angle, side, angle. So I can go ahead and use law of sines. First angle I'm going to find is C. So C. Now, this is going to be 180 minus 64. So again, sum of the angles of a triangle is always 180 minus 36. And then when you run that through your calculator, you're going to get 80 degrees. Alright, so that guy's going to be 80. Alright, and so then, you know, like I did before, I'm going to put C equals, what else are we looking for? A and B. So this is 80 degrees. And now, we're going to go ahead and write that in for C. Just right here. Then we're going to go find A and B. It doesn't matter the order. So A. I'm going to take A over the sine of 36. And that's going to equal 17 over sine of 80. Now, I'm not going to solve this. I'm just going to set out the equation in class. The next time we see you, I want you to have A equals solve for us. All right, let's go after B. Now, it's going to be B over the sine of 64. Whoops. I accidentally put a 6. So B. That's a B, not a 6. B over sine of 64 is going to equal, and again, 17 over sine of 80. I can use that once I know that pair is known. And I want you to have this solved for us also. All right, this last theorem is real easy. If you need to pause to draw these two triangles, go ahead and do so. All right. Find the area of a non-right triangle. So we can't just use areas half base times height. So this is used for a side angle side triangle. And so for instance, if I'm given information about this side, this angle, and this side, then I'm able to use this formula. And so the formula would look like this. The area would equal half the two sides multiplied together, B times C, times the sine of the angle between them. Very easy formula. All right, so let's do example 2. Let's find the area of the following triangle given this information. Again, if you need to pause to draw this real quick, I have a side angle side triangle, so I'm allowed to use this formula. Now, we're not solving this triangle. We're just finding the area, which is real quick. Area equals half these two sides multiplied together after I filled out the given information times the sine of the angle between them. And it didn't matter that I had side angle side here and side angle side here. Any group of side angle side, and you can use this formula. All right, it's a very nice quick formula. And you just run this through your calculator. Again, make sure you're in degrees. And you should get 118.54. And since this is area, it's going to be feet squared. Again, we cannot use Pythagorean theorem. We can't use SOHCAHTOA. And we can't just say area is half base times height because this is not a right triangle. All right, that'll do it for today.